Right. X1 4. X1 4. Write down determination of. Determination of. Determination of. Internal resistance of a cell. Determination of internal resistance of a cell. Using potentiometer. Determination of internal resistance of a cell using potentiometer. Determination of internal resistance of a cell using potentiometer. Okay. So let's start to do the circuit until others are coming. So there are some students to come. Right. See. In terms of potentiometer, this part remains same in any kind of potentiometer. Right? And the secondary circuit changes. Only the secondary circuit changes. Right? Now, to find internal resistance of the cell, there should be a current flows through the cell. Right? And to have a current flow through the cell, this should be connected as a closed loop because if only the single battery is connected, right? There won't be any current through the cell. Right? But when we get a loop, then there can be currents through the cell. Right? Right. So when comes up, right, again, always the same as zero. Using the apparatus, oh, using the apparatus, first using the materials, right? Materials. Very much same as go, right? Like every other problem, is there materials. Materials, mention materials. Potentiometer, a potentiometer, a potentiometer, a potentiometer, an accumulator, right? An accumulator, an accumulator, an accumulator. Two plug keys, two plug keys, two plug keys, two plug keys. Two plug keys and one tap key. Two plug keys and one tap key. Two plug keys, one Tap key. One tap key. A dry cell. A dry cell. A dry cell. A dry cell. Send a 0 galvanometer. A dry cell. Then send a 0 galvanometer. Send a 0 galvanometer. Send a 0 galvanometer. Slide again. Slide again. Safeguard resistor. Safeguard resistor. Safeguard resistor. Within brackets, about 5 kiloohms. Within brackets, about 5 kiloohms. About 5 kiloohms. Right. That's all. Now, as apparatus, take it out. As apparatus, take it out. Take out the apparatus. Take out the apparatus. In the apparatus. Take out the apparatus. Right. Take out. Materials ചെയ്യുക. Materials ചെയ്യുക. apparatus ആദ്യം. Materials के डाली के बनाया होगा मेरा सुनने के लिए प्राइस से लगाई 2 का केस 1 का केस राइट और कमोडिटी का इनका से Okay, finish. Right, now since I have explained the background about potentiometer in the last experiment, right now usually you can do this as an experiment. The content in the experiment is will be high, but the thing is, I explained the background things about potentiometer before, right? So then without explaining things, we can move, right? Other then method, sorry, yeah, method, right? So here, what we do is this. Listen. Now, our target is finding internal resistance of the loop. To find the internal resistance, first thing is that internal resistance should be activated, right? That's why only the cell is not connected. If only the cell is connected, right? If only the cell is connected at the balance point, no current flows to this part. If no current flows, right, as I explained before, that internal resistor is inactive. Right, active with that. Then you have to make a secondary circuit here, secondary loop, right? Sub loop here to flow the current. Right? Now what happens is this. Now this is how the circuit works. Now even at the balance point, let's say balance point is here, even at the balance point, right? Even at the balance point, since this is a separate loop, this is active, right? This is active. The reason again is since we are finding R of this battery, right? If there is a continuous current flows through this is a dice, right? Maybe dice yeah. Maybe not accumulator. Accumulator will provide the steady current, but not the dice. Therefore, this key is active, right? They would have label active. These are active. Right? And the comma that they have keys. They have keys. Right? They are not clear. The reason to use an active here is when this loop is closed, there is a current flows through this loop. And if that is continuously closed due to the dry cell is going to discharge. Right? Discharge the time of the instant current going on that is the. That's one idea also you can keep that in mind. Okay, see now when this is closed, right? Yes, it's a closed area. When this is closed, from this, there is a current flows through this sub loop, secondary loop, like this one. Right? When a current flows, internal resistance is active. Right now there is active. But at the balance point, still there are no currents to the galvanometer. At the balance point, balance again, right? There are no currents to the galvanometer. Since there are no currents to the galvanometer, if this point is C, there is no potential difference across any of these devices. Up to here, that will be C. Right? Since this point is A, this is A. If that is A, this is also A. If this is C, this is also C. Right? At the balance point, since there is no current through the galvanometer, since there is no current through the self resistor, right? No potential difference across this part. Then if this point is C, this is also same as point A. Right? Now, what we are doing is this. Finding a balance point again. After properly connecting this, keeping finder at A and B, checking the reflection of galvanometer, whether it passes through 0 to one side to the other, right? Accommodate karna. Then you have to find the balance point, right? So at that balance point, there is going to balance to AC, right? Make a balance point, right? From the battery, you can write this potential difference either as E minus IR. From the resistor, you can write the same as IR. Because this battery, this resistor, are in a series in a parallel combination now, AC to AC, right? Now, this is what we do at balance point. At balance point. At balance point. At balance point. Again, VAC equals VAC. VAC equals VAC. Now, from the circuit and from the wire, we can expand VAC from the potentiometer wire, that is K. If K of the potentiometer is K, right? Potential potentiometer is K, KL equals VAC. From the circuit, you can either write the same using the cell or using the resistor, right? I'm going to use the resistor. Using resistor, this is IR. right? Now we need I, right? This is a closed loop. To find the current of a closed loop, what are the measures here? Kirchhoff, right? Obvious method is Kirchhoff, right? Apply Kirchhoff. Then for this second below loop, apply Kirchhoff laws, right? Then in this section, sigma E equals sigma IR. Sigma E only one factor E, right? Simple line current, simple line flows through both resistors, simple R and capital R, and simple R plus capital R. Current in the circuit is given by E over simple R plus capital R. Right? Plug this current here. Plug this current here. Then K equals I is E, then R over R plus R. Right. Now check the variables again. Check the variables again. Check the variables again. Now with the experiment. With the experiment. From these variables, what are the constants and what are the variables? K and what? Constant variable here. K. Constant L. Variable simple R. Constant capital R. Variable, right? Whereas points here is a constant. Then capital R is a variable. Capital R is here. Whether in. Now we are going to change the resistor. Right? We are going to change the resistor. Now, instead of just a resistor, right? Usually we connect a resistor box here. Right? We connect a resistor box here. Simple and we connect a resistor box here. Right? Now, R is our independent or dependent. R. How change current? R change current, L change. When R changes, only L changes. Then R is our independent variable X. Right? R is X. Right? R is X. R X. L is Y. Right? But we need a linear curve. We need a linear variation. To get a linear variation, right? Now R is spread to two sides, right? Put this one more. After both sides one more equals this is R plus R over ER. Now you can divide these two terms separately. This side is still 1 over AL. If we divide this separately, this becomes R over ER. Right? And this becomes 1 over E. R cancels. Right? Then R cancels. Then this cancels. Then subject 1 over L. Then K R over E. Since my variable is R, I'm isolating this part. And K over E. Right? Now, to get a linear variation, right? We must consider 1 over L as 1 over R as independent variable and 1 over L as dependent variable. Right? L R then variables are 1 over R and 1 over L. Variables are but our axes are 1 over L and 1 over R. Right? Now the graph is right. This is considered as X. Right? This gradient intercept dependent. Right? Now, if we plot the graph, right, shape is y equals plus y is 1 over L, the limits per centimeter, right? And 1 over R, x 1 over R per ohm, that is n plus C, right? This is a graph. Intercept is K over E, and the gradient of graph is KR over E, right? KR over E, right? Now, what is our target? Target. Simple R, internal resistance. What's the easiest way to find simple R after this? Gradient again, intercept again. Gradient over intercept, right? Gradient over intercept. We are not going to find K, right? We are not going to find K. K is just used for the sake of writing these equations. Right? K one will be right? K one will everything up in one is a relation. That's the thing. Right? So usually we don't find K for doing experiments. Right? K use karna, cancel karna. Right? Alright? Now, easiest and the best way to find simple R is gradient over intercept. Gradient over intercept is simple R. So likewise, we can find simple R if the graph is plotted. right? Right. What's the idea? Right. Then electricity අලුත් division එකෙන් පස්සේ experiments හතරයි තියෙන්නේ. Right? When they ask for experiments, so you can easily guess what might come. Right? Modified වෙන්න පුළුවන්. But if there is not a modified one, there is something out of these four. Right? Sometimes say four can be modified with magnetic fields here. Right? Equations similar here. But rare. ඒක රෙයයි. වෙන්න බැරි නෑ. ඒක රෙයයි. මේ ඒකේට electricity question එකනේ. ඉතින් මේ හතරෙන් ඉඳලා එන්නේ මේ last එක. හතරෙන් ඉඳලා එන්නේ. ඒක ඉතින් ඒවා වල prepare කරලා ගන්න. තරමාරේ නිකන් ගෙදරින් අරන් යනවා වගේ ලාවන ඕක. මේ council structure. right? They are the ones you are bringing from home. අනිත් ඒවා වෙල ඉඳලා මොනවද කරන්නේ මේකේම නෙමෙයි. This is something you know. අනිත් එක කලින් දැවා සයිට් එක දැක්කම මොකක්ද දැකලා ඉවරනේ you have to think at that moment and then only you can do it. Experiments නෙමෙයි. There is something from something you know before, right? ඒව නිකන් අරගෙන යන්න පුළුවන් ලකුණු. පොඩි modified parts here පුළුවන්. But from 80 marks here, right? You can assure like 65, 70 marks, right? 65 or 70 marks, like 65 marks, right? If you know all experiments. Additional thinking say usually for the last part, last two parts, thinking are added on, right? ඒ වගේ එකක් දැකලා දානවා තර understanding එක ඉක්මන. ඒක පුළුවන්. ඒක නැති වුණොත් අර පාඩම් කරලා ඉගෙන ගන්න around 65, 64, 65 වගේ වගේ ඉගෙන ගන්න පුළුවන්. All right. What is that? Okay. Then mention theory. Theory. Write down. If balance length. Write down. If balance length. If balance length. If balance length. If balance length. Is simple L. If balance length is simple L. Simple L. Right? Start from here. Current එක බලන්න ඕනේ. Right? මේක current එක then plug the value divide මේක code එක up to this point. අර point එක දාන්න ඕනේ. Why extra variable resistor used in circuit? I mentioned before in the last experiment also. Last video, that is optional. Right? That is optional. Why we are using the variable resistor? To change K is here. To change K. Right? That is optional. Calling your viewer. I will give it back. Optional. Right? This one is optional. You are there in the last one. Okay, right? Method. Whether that's why. That's why. Connect the circuit. Connect the circuit properly as mentioned under. As mentioned under apparatus. Connect the circuit properly as mentioned under apparatus. Keep strategy as 10 we are calling together now you repeated there. Right, second one. Keep strategy at A and B. Keep strategy at A and B. Keep strategy at A and B. Respectively. Respectively. And check the reflection of galvanometer. And check the reflection of galvanometer. And check the reflection of galvanometer. Whether it passes to 0 from one side to the other. Whether it passes to 0 from one side to the other. Whether it passes to 0 from one side to the other. Passes to 0 from one side to the other. Next point. Cross S2. Cross S2. Cross S2. Cross S2. And find rough balance point. Cross S2 and find the accurate 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 balance point. And find the accurate balance point. Next point. Next point. Repeat the same. Repeat the same. Repeat the same. So minimum of. Repeat the same. Repeat the same. So minimum of 6 different values. 6 different values. For capital R. 6 different values for capital R. By changing the resistance of resistor box. By changing the resistance of resistor box. Label this as resistor box. Label this as resistor box. Right, next. From the variation between. From the variation between. From the variation between. From the variation between. 1 over L and 1 over R. 1 over L and 1 over R. 1 over L and 1 over R. As mentioned under theory. Right, and we need minimum of 6 values, right? By changing R, then R changes, when R changes, L changes, so we need R 1 over L and 1 over L. L and 1 over L. Right, this is in ohms, this is per ohm, centimeters per centimeter. right? So what we need to plot the graph is these two, right? One OR and one OL. Plot the graph, one OR and one OL. Plot the graph. Right, next point. Next point. Determine simple R. Determine simple R using gradient and intercept. Determine simple R using gradient and intercept. As discussed under the as discussed under the as discussed under the right. Right, that's it. That's it. Remarks. Remarks. Right, now common again because they are common with the previous one. They are not right. One day. Now using this setup, we can't measure very small potential differences. Right? We can't measure very small potential differences. Right? So therefore, when we choose this cell, right? We have to choose the cell, right? Choose the cell as our balance length is falling somewhere between at least 40-60 range. Right? If there is too small or too large, right? Either sides, it's going to make errors. Right? So again, modification very small mind if you need to measure small potential differences, you have to reduce K. Right? Unless otherwise, you are going to get a very small L when measuring small potential differences. Right? So idea for right? For a given value, if you are choosing E, right? It should be as you are getting the balance point somewhere between 40-60 at least, right? As a first point right now, first point. This circuit is not capable of. This circuit is not capable of. This circuit is not capable of. This circuit is not capable of measuring small potential differences. Not capable of measuring small potential differences. Right. Write down the reason below. Write down the reason below. Write down the reason below. A very small balance length is obtained. 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 When measuring small potential differences. When measuring small potential differences. Hence percentage errors are high and incorrections of potentiometer and incorrections of potentiometer and incorrections of potentiometer cannot be neglected. Cannot be neglected. Cannot be neglected. Cannot be neglected. With respect to a small balance length. Cannot be neglected with respect to a small balance length. Cannot be neglected with respect to a small balance length. Right. Next thing. Connecting this connecting this secondary loop is a must do thing, because otherwise, if we don't have this secondary loop, right, we don't have any other way to activate this arm, right? Activate, right? The whole purpose of doing this circuit is connecting the circuit like this is activating simple arm, right? Right now, next point. Connecting the secondary loop, connecting the secondary loop is compulsory. Connecting the secondary loop is compulsory. Connecting a secondary loop is compulsory to flow a current through. To flow a current through. To flow a current through. Capital E. To flow a current through capital E. To flow a current through capital E. At the balance point. At the balance point. To activate. At the balance point to activate. To activate its internal resistor. To activate its internal resistor. To activate its internal resistor. Right. The next thing is about this tap key. Right, tap key is the limited Q. Right now, we just need to get the reading when a current flows only, at the point when the current flows only, right? Then the tap key is used here, right? At the very point when the current flows, you can tap the key and get the reading. That's it. Main circuit here, tap key simple issue because we are using an accumulator. That's the reason. Make accumulator. This won't discharge. Right? This is just a right shell. This is just a right shell. It discharges. Right? Accumulator can never shell is back to the but it won't discharge. Right? Then write down. A tap key is used. 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 A tap key is used to minimize discharging of capital A. To minimize discharging of capital A. By flowing an instant current, by flowing an instant current, by flowing an instant current, when the reading is taken, by flowing an instant current, when the reading is taken, by flowing an instant current, when the reading is taken. Right. Now, next question. Listen. Next question. Can we use a rheostat instead of the resistor box here? A rheostat here. Our variable resistance again, questions are but can we use a rheostat instead of the resistor box here? What's the reason? Well, to plot the graph, R should be known. R should be known. Can we find the resistance of a rheostat? You can't. Change right? You can't find the resistance of a rheostat. But here, the variable resistor is mentioned here. Right? Because we are going to find R and L. Right? R than the right? So only resistor box is possible to be used here. Right? Next point. Next point. A rheostat can be used. A a rheostat cannot be used for the secondary circuit. A rheostat cannot be used for the secondary circuit. A rheostat cannot be used for the secondary circuit. Since it does not give a non-resistance. Since it does not give a non-resistance. Since it does not give a non-resistance. Right, next. Now, when you are choosing the cell here, right? When you are choosing the cell here, right? First thing, it should be less than E naught, right? If that is greater than E naught, right? You can't get a balance point of Q. If this is greater than E naught, then it should be less than E naught. And always we are choosing the cell as the balance length is falling between 46 range at least, right? Next point. Next point. No need to mention invert. Mention this way. E should be less than E naught. E should be less than E naught, right? E should be less than E naught. And right. Now, even if E is greater than E naught, that doesn't matter if it measures the potential difference when the current flows. Right? Again, negative 2 volts with the negative 3 volts not on. If this potential difference across this current flows is 1.5 or something, or no something. Even one balance even with that, I mean, this is balance to this, right? IR. Right? Even in value, that is E minus IR when current flows. Right? But be on the safe side, we are using this. Make a battery not but it goes too much. When the battery again, better than 8 volts battery right? 8 volts battery resistor का potential करता और potential difference से करता हूँ potential difference से 3 volts करेगा right? That to some extent, maybe to some extent we have a kind of freedom to go a little bit beyond E, right? If the potential difference is less than that value, right? Okay, what did I say? Negative, right? E should be less than E naught. E should be less than E naught. To get a balance point. Oh, to get a balance point. Oh. Even if E is greater than E naught, or even if E is greater than E naught, or even if E is greater than E naught, or even if E is greater than E naught, if potential difference across cell is less than, if potential difference across cell is less than E naught, still the balance point can be obtained. Still a balance point can be obtained. Still a balance point can be obtained. Right. Then the reason we use accumulator is very much same as before, right? Same. Next one, accumulator is used to provide a steady current for a longer period of time. Accumulator is used to provide a steady current for a longer period of time. Right. Next one. Right. Last day you up. If you need to check whether accumulator is discharged at the end of the experiment after taking all these 6 readings, right? According to your question. Again, to check whether accumulator is discharged, take the first reading again. Just capital R to the initial value and take the first reading again and compare it with the initial value. Right? Next point. Next point. Take the initial reading again. Take the initial reading again. Take the initial reading again. At the end of. Take the initial reading again. At the end of. Take the initial reading again. At the end of the experiment. Take the initial reading again at the end of the experiment. Take the initial reading again at the end of the experiment. To make sure whether the accumulator is discharged. 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 Right. That's it. Any questions? Any questions? Now check what we have done from the beginning, and with this we mark the end of electricity practicals. Right? The electricity here, right? Now after this I'm going to take the properties of matter. Right? Check electricity experiments right? Exactly about these 4 electricity experiments we discussed. Right? You can ask anything before we move on to the next. Right? It was electricity. It was electricity again. It was the properties of matter. It was the surface tension. Right. Check all of them and ask the questions. And if there is clear, say it's clear online. Right? Anything? Right. Right. Anything? Yeah. One second. Lagi saya mau dia listen. Right, listen. 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 There is a question. When you draw circuits, right, as the symbol of any switch, this can be used, right? This does not mean that this is the standard symbol of any switch, any type of switch, any type of switch. One switch symbol, right? මොන battery එකක්ද තේරිද වගේ මේක accumulator එක. අපි එහෙම කියලා එහෙම අදින්නේ accumulator looks like this. Accumulator look like this. මේක තමයි accumulator එකේ. Right? Very simple there. But when it comes to the cases where you have both tap keys and plug keys, to identify between tap keys and plug keys, right? You can draw plug keys like this, right? That is fine. And even if you draw it like this, that is also fine, right? Make it out of the there. Even that that is fine. Only have a little right? And this is used for the identification purpose, right? Name of the that is for the identification purpose of plug keys and tap keys, right? If not, as an overall, any key is drawn like this, right? Take a right? That may seem like a symbol, this is not a symbol of a switch, right? This is just a symbol used to identify a plug key, right? Anything else? Right? Anything else? Right. Then let's move on. Amazing. Last. Right, man. Okay.